morning, all of you. I am Birva Solanki. I am Assistant Professor in the CSE Department, AKGEC Margarg Engineering College. Today we will discuss the first lecture of DFA and some concepts of DFA and strings and string and tuple and alphabets, etc. So we will start from the first. Here we discuss some things of the automata, some terminology. The automata is the system that performs some function without human interaction. The plural of the automaton is automata. So we further use as a automata concept. Keywords. The automata theory is study of the abstract model computation machine and the computation problem that can be solved using these machines. Abstract machines are simplified mathematical model for real computation. It can be the automata in the computer. The automata like work as a with CPU with some programs and that receive the input and perform or computation them and then generate the output. And these the actual things, how the function and how the automatas work. It is perform f of x equal to x square plus 3. What is the output of that? Here the automata can see here like, and the program is that, and the input text by the automata is x equal to 5 and then perform computation like x equal to 5, then 5 square plus 3, the output is 28. The output is generated here, f of x equal to 28. Now we will start DFA. We will discuss some concept that we use in the DFA that are, first is alphabet. Alphabet is a finite non-empty set of symbols. It is represented by, here see, sigma. The example of the alphabet here, sigma equal to, it is represented by sigma. So sigma equal to 0 1 is a binary alphabet. 0 1 is the actually is the alphabet in the form of binary, and next the alphabet is in the form of decimal, that is 0 1 2 3 4 5 6 7 8 9 10. It is a decimal alphabet over sigma, and the sigma also can be considered A, B, C and the Z. It is lowercase alphabet. Here we what is the alphabet? The alphabet is a finite non-empty set of symbols. Next thing is that will be used in the DFA, that is string or word. A string or word is a finite sequence of symbols. Sequence means symbols here 1 0 1 1 0. It is the sequence of symbols. So 1 0 1 1 0 is a string that a sequence of symbols. It means symbols is 1 0 1 1 0 etc. or and it can be other as a B, C, like that. So the next thing is length of string. Length of string, it is represented by sigma. Sigma power k is the set of string of length k. Here k represent here the length of string. It is represented by, suppose w is a string, then length equal to k, means if w is suppose a b c, then length is 3 and it can be length string can be suppose 0 1, the length is 2, etc. It can be C in the form of sigma equal to AB, then length. Suppose AB is the alphabet, then length of the string, if we write sigma equal sigma power 0, then that is consider only the epsilon, means its length 0, called epsilon is represented here. A length 1, it can be length 1 of a string, it can be represented or write sigma to the power 1, or it is in the form of string A or B. It means that A to the power A equal to 1, B equal to 1, it is can be measure the length of the string. Suppose the length of 2 of a string, it can be write here equal to it is the different types of string, that length 2, AA, AB, BA or BB. It means how can you calculate the length? AA equal to 2, AB equal to 2. It can be measured like that. So, the length of this string can you find like that. How can we find the reverse of a string? Reverse of a string W is also a string. It can be represented as W to the power R. Suppose W is the length W is the length, XY length can be represented as W, then the reverse of R equal to it is reverse here can be C. Now the concept of the substring. Suppose XYZ is a string is represented by W, then the substring of R can be write sigma X Y Z X Y Y Z ZX and X Y Z. It is all are the substring of string X Y Z. Now we find the prefix of a given string. Now we see how to calculate the prefix of a string. Suppose XYZ string can be represented as W, then it can prefix R, epsilon, X, XY and whole string also a prefix of given string XYZ. Now the suffix of a string, how can you calculate? Here we see W equal to XYZ, then the suffixes are here we see can be write epsilon, so epsilon here and the suffix of XYZ, the XY suffix equal to Z. So here we write Z, and the suffix of X equal to XYZ, then it will be right here, and the whole suffix of XYZ it can be right here. Now we will discuss other concept. What is the language? The language a set of string over sigma is called a language, and can be see how can you define language. Suppose example L1 equal to is a language. How can you define language? W equal to 0 1, it is the alphabet 0 1, and W is defined a language as W has a equal number of 0 and equal number of 1s. It means that जितने number of 0 होंगे उतने number of 1 होंगे अपने string में. It can be represented in the form of string. So we write here number of 0 and number of 1. So here we see from the language, and it is a string 0 and 1. It is the equal number of 0 and 1. Here C 0 and 1. So equal number of 0 and equal number of 1, and C the other string 1 or 0, it is equal number of 0 and 1. Here C, here 2 number of 0 and 2 number of 1. Here we also see number of 0 and number of 1 both are equal, and here we see 0 1 0 1, here we see equal number of 0 and equal number of 1, and so on we see in the given strings. Now the define another language L2 equal to W. W here we see A and B is the alphabet or is the star in clean closure, and the length of the string is less than equal to 3. So here we write the string for the given language can see epsilon, it means less than equal to 3, it means length 0 and length of it include epsilon and length 0 and length 1 and length 2, length 3, equal length of 3, equal length of 3 or it is the possible of all AB. Here be some changes for the it can be write exactly 0 and 1. So the string can be generated in the form of 0 1. So the string generated from the given language here we see. Now we discuss the clean closure. It is the important property in the context of the automata. So we discuss the clean closure represented as a sigma star, and it is set of all strings of possible. The clean closure represented as a sigma star is set of all possible length. It can be represented as sigma star sigma 0 means that the length of the string is 0, a length of 1, a length of 2 and length of 3 that इस तरीके से. तो इसमें जो भी लेंथ की पॉसिबिलिटी होगी सभी पॉसिबल लेंथ की स्ट्रिंग को इसमें क्या करेंगे we include the all possible length of strings. It means the 0 1 2 3 like that. The example is see we see sigma equal to AB. It means that AB is the alphabet for the language, and sigma star yes sigma star equal to epsilon, it include the null comma length 1 length 2 length 2 like length 3 and length 4. It is the possible of all length. The positive closure means that it consider all possible length and exclude the epsilon from the strings. The positive closure represent as sigma plus is a set of string of all possible length. It exclude the epsilon from the strings. Here we see length of 1, length of 2 and length of 3. So here we exclude from the epsilon from the strings. Here we see if sigma is alphabet AB and the string can be include here A, it means the length 1, length 2, length 3. It does not include epsilon. It can be write epsilon and the other respect lambda etc. Here it does not include. Now we discuss the finite automata. What is the meaning of finite automata in the informal definition? The finite automata is a mathematical model that works for the several computer algorithm. It is called finite because it works on a finite set of input symbols with a finite number of state and give output in finite time. Here we see from the diagram, it is represented as a string in the magnet type store, and write the reading head string, and finite control, it is the controller, and generate the output according to the inputs. The application of the automata, the following application can be see. The application of finite automata, first is the string matching. Suppose ABC is the string, ABC is the string, so means that the automata is accept the string or not. So matching is the application of automata. And the lexical analysis also, and design analysis of digital circuit, we can use a model for learning and decision making, automatic packing machine like that. Now the finite automata can be divided into the two parts. First is the deterministic finite automata, and next is the non-deterministic finite automata. It can be a short form of deterministic finite automata is that DFA, and the non-deterministic finite automata can be represented short form NDFA or NFA. Here we see some other points important too. For a DFA, deterministic finite automata, the machine moves to a particular unique state from a given state and given input, that is why it is called a deterministic. Deterministic means that here we see the 0 is the input state, 0 is the initial state, and we take a input A on the initial state, then we move from Q0 to Q1, it is the unique, and again if we take an input as a string on the initial state Q0, then move on the Q2 state, it is also a unique, so it is called a deterministic. And as the number of states in the DFA are finite, so called a deterministic finite automata. So deterministic finite automata means the deterministic means that it is a moves on the particular state. If we read the input on the unique state, and the number of states in DFA is finite, so it is called a finite automata, deterministic finite automata. Here we see, here we discuss the formal definition of the DFA. The DFA can be deterministic finite automata is contain the 5 tuples. First is Q, second is the sigma, and followed by delta, Q0 and F. And Q0 is a non-empty finite set of states. Q is a non-empty finite set of states, and sigma is the non-empty finite set of alphabet, and delta is a imported function in the context of DFA that describe the all things. Delta, it means that how to move from particular state to next state if we read the given input. Suppose Q0 initial state, or here we read some alphabet, suppose A, then we will move on to the next state. It means that it can be Q0, Q1, etc., Q2, Q3 is like this. Here A is the input alphabet. So how to write the, and how the transition function work, here we see from the given equation. And Q0 is the the initial state that belong to the set of final set of states, and F is the final state that belong also a set of states. It can be equal to the number of state or less than or subset. It can be further can be DFA can be how the some function or can be right or can be represented here for the DFA. Suppose it is the transition diagram of DFA that contain the total number of state Q0, Q1, Q2. So, here we write Q, it is represented, it is represent all the set of state, and Q0, 0 and 1, 0 and 1 here represent the alphabet. Alphabet can be represented in the formal definition like the sigma, and delta is the delta transition function, and Q0 is the initial state, initial state, and Q2 is the final state. So, how the machine can be represented for the given transition in the form of the DFA in the formal definition. The Q0, Q1, Q2 is the total number of state, 0, 1 is the input alphabet, and delta is the transition function, Q0 initial state, and Q2 is the final state. The transition table also describe for the given DFA. We will make a transition table for the given DFA. Here the transition diagram, this is a formal definition of the given transition diagram, and this is the transition table for the given transition diagram. It is the movement, let us see how can it is made. Here represent the present state Q0, Q1, Q2, this is the next state. If we read 0, 1, then we forward into the next state, and if we read 1, we will forward to the next state. If we read Q0 state, if we on the present state Q0 and read the input alphabet 0 and then forward into the Q0 state. It can be see Q0 is the present state and read the input alphabet 0, then forward to the Q0. So, Q0 and the if we into the if the present state is Q0 and the if we read one input at the Q0, then forward into the next state, that is Q1. It can be see Q0 and if we read input 1, then forward into the next state Q1, and so on. If we on the current state Q1, then if we read input alphabet 0 and forward into the Q2 state, Q1 is the present state और input alphabet आपका 0 है, then forward into the next state, that is Q2, forward to the Q2, and if we read if Q1 is the present state and read the input alphabet 1, then forward to the Q0, that we see here. If we read one input, then forward into the or move into the Q0 state, and we see that also, and so on. Thank you.